Okay, I thought I would help you through the last three problems on the review here that we haven't had a chance to look at yet. I think you'll do very well. Some of you might even have thoughts back to geometry about SOHCAHTOA, but I'm going to try to avoid those thoughts and use what we've done here in trig to find this information. So, for example, in this picture here, we want to find the value of x. What I realize I'm going to look at here is that I have the x side wanted and the r side known. And this angle in the corner here, this 37 degrees, is theta. So when I think of a trig function that relates the x side to the r side, I'm thinking of the cosine function. And now it's just a matter of plugging the numbers in where they belong. So it's the cosine of 37 degrees that equals the x side over the r side. Now, to get this solved, to solve this equation, we would want to multiply both sides of the equation by 15. And just make sure you don't multiply the 37 degrees by 15. It's going to be 15 times the cosine of 37 degrees. And now it's just head to the calculator and do this, but before you push the buttons again, remember, you must be in the right mode, so we must be in degree mode when working with degrees. If you push 15 times the cosine of 37 and you're in radians, it's going to be the wrong answer, okay? So grab my calculator here, make sure I'm in degree mode, and then type 15 cosine of 37. And that missing side called x looks like 11 point, I'll just go to the nearest hundredth here, 11.98 feet. Okay, now I changed one little detail here, and it really messes everything up if you aren't aware of what you're trying to find or what you're looking at. Notice the different orientation of this triangle. This is not how we would see things in trig. So if you have the SOHCAHTOA mentality and think opposite and adjacent and hypotenuse, you're going to do just fine here, but I don't really want to bring in geometry to solve this problem. I'm going to try and make it look like a trig problem. Okay, so what I'm talking about here is that if I have my quadrants and I look at triangles in those quadrants, we've kind of had the idea that this is how we draw in all four quadrants. And the reference angle is always this angle inside right here is the reference angle. Now, if you kind of look at my picture that I drew, I put the angle known up in this corner, and in no case is that one of our angles we've ever referenced in trig. Okay? So the first concern is to get this triangle turned or to look like one of these that I've drawn that look like a bow tie. And simply stated, I think I can do that by, okay, I gotta break that for a second, just a second. There we go. I had that all tied together. But simply stated, I can take this guy, and if I turn him like this, actually, okay, let me move that to the middle. Do you see how it now looks like the 37 degrees is the reference angle like we want? Do you see what happened to the side I used to call x? It's now y. Okay, so perhaps, let's get this out of the way now, perhaps we should think about this side not as x, but as y, and this side not as y, but as x, because this angle, the reference angle, is in the proper position now to be thought about in trig. In its current orientation, it was the wrong angle to think about for trig. Okay? So now the question comes down to this. I wanted this side right here, the y side. I know the r side. So what comes to mind when I think of y and r is the trig function sine. And sine of the angle 37 is equal to y over 15. Now we'll multiply by 15, and we will know the y if we take 15 times the sine of 37. Again, focus on degree mode because it's 37 degrees. The y side in this triangle is 9.03 feet. Okay? Okay, so I returned the triangle back to kind of the original orientation to discuss a different situation that arises. So, well, first of all, you notice I called the r side x. Do not get hung up on what the variable is for the side. You can change that if you need. If you would rather call this r instead of x, I'd be okay with that. Okay, but just realize that it's the radius that we're actually looking for. So what trig function discusses the x side and the r side together? Well, that would be the cosine. So again, I would begin by identifying which trig function brings the information together that I want to use. And cosine is x over r. So now cosine of 37, and I can say that here because this is actually, like we've seen in trig, the reference angle in the corner there. So cosine of 37 degrees equals the x side 15 on top of r. Okay, so now that this one's set up, it's a little bit different. It looks like r is in the bottom, and you really never want your variable to be in the bottom of a fraction, and that's our first concern. So what we're going to do here is get r out of the bottom of that fraction by multiplying both sides by r. Usually that's confusing to people when you're first encountering it because you don't think you've accomplished anything, but now you have an r times the cosine of 37 degrees that equals 15. And then now, if you looked at that and said, how do you get r by itself, it kind of is a little bit more easy to understand. Divide by the cosine of 37. So, oops, let me rewrite that. Cosine of 37. So, to find the answer for r when it's in the bottom, the first step is to get r out of the bottom, or any variable you're seeking. If it's in the bottom, get that out of there. And then find the answer by taking 15 divided by the cosine of 37. And that's about 18.78 feet.